Hi, everybody. Um, my name is John Horgan. I'm director of the Center for Science Writings, which has been putting on these events for 18 years now here at Stevens. So welcome to our first event of the semester. Before I introduce our speaker, I want to tell you about two upcoming events this fall. So on November 1st, neurobiologist Robert Sapolsky of Stanford. He's written a lot of popular books on biology and behavior. He'll discuss his new book, which is coming out any minute now. It's called Determined, A Life of Science Without Free Will. So rather than Sapolsky giving a lecture, we agreed that I would interview him. We'd have this conversation. And I'm hoping that will be interesting because I absolutely believe in free will. On November 15th, Oxford philosopher Amiya Srinivasan, who is quickly becoming one of the most famous philosophers in the world, she'll talk about her widely debated book, The Right to Sex, Feminism in the 21st Century. So I hope all of you make it to these upcoming events. All right, now for today's speaker. Erik Larson is a computer scientist, and he's both a builder of AI systems and a critic of the culture of AI. He's the author of The Myth of Artificial Intelligence. Here it is in paperback now, which pokes holes in the hype surrounding AI. And it's really a great book. It puts AI in its historical context and its philosophical context in a way that's especially valuable for what's going on right now. Erik also writes about AI and other technologies on a Substack newsletter that he just started called Collegio. That's Colligo. Collegio, is that?
Colligo.
Colligo. So it's the same
It's a
root as,
Latin word for to collect together, to bring
yeah,
together.
so same root as college, I assume.
Yes,
Yeah.
exactly.
It's a fantastic newsletter. I'm a subscriber, so check it out. So when all this brouhaha about ChatGPT erupted, I forget when that was, a year ago, a couple of years ago, I knew I had to get Erik to talk about it and to help put it in context for us. So I'm really thrilled that he's here today. So he's going to talk for a little while. And then I'm hoping there will be time for questions, and you can submit your questions by Skype. So anyway, Erik, take it away.
Okay, thanks, John. It's obligatory for me to say this. So I was working as a research scientist, or what we would say like an AI scientist in the field, since January of 2000, and I decided to write this book somewhere in the 2010s. And I left my job, and I was sort of completely obscure as a writer. And I reached out to John, and I will never forget the feeling of gratitude that I had when he read one of my initial manuscripts and allowed me to use a quote from him. So John is a great guy to know if you're starting out as a writer. And I just always have to say that because it's really been a special moment in my heart that happened. So the ChatGPT is a very interesting phenomenon. My field is natural language processing. I don't work on conversational AI specifically, but I do work on the interpretation of natural language by modeling it and building AI systems to model it. And so I'm going to start out with a kind of it's frankly it's an admission, frankly. At the time I was writing the book, I used examples of inherently hard problems that AI systems would have a very difficult time solving. And it turns out that ChatGPT can solve, and I went through the examples in my book. It turns out that it can solve about 70% of them. So I thought maybe 30%, 70, and it turns out it's like 70, 30. So I think it's important, just as a, with my scientist hat on, rather than my critic hat. I think it's important to acknowledge that it's actually a very powerful technology, and we just couldn't have reproduced that kind of conversational capability even a decade ago. We like I was working on trying to interpret language, and there's little problems in language. One of them is called co-reference, and so it famous like so here's the famous example from 1971. Actually, the council refused the demonstrators a permit because they feared or advocated violence, and then you ask the machine, who who would fear and who would advocate, right? And so it would be the council that feared the violence, and the demonstrators that advocated it, and so on. And so these kind of reference problems we were working on, and we were having limited success solving them. They're called Winograd schemas after Terry Winograd, the founder, or the one who first proposed it. And it turns out that GPT-3.5, GPT-4 certainly solves a great number of them. And so it's sort of like there's this magic trick going on in the field right now. Like, how is this possible? Like, what happened? So I want to start the talk by acknowledging that I think this is a legitimate moving the ball forward in terms of interpretation, in terms of natural language processing, which is a subfield of AI. And I think it's important. I think it's important to acknowledge that. Now, I'm gonna kind of not bury the lead, and I'm gonna tell you what I think it actually means right now, and then I'll go ahead and try to prove this as I get into the talk. But I think what's happening is, as we see success in AI, quite significant success in the case of the GPT models, it's increasingly apparent that there's a gap between tool production and creating a new entity or a mind that we're sharing space with on the planet Earth. So I think the original kind of sci-fi idea of AI was that as we create powerful or obtain powerful results, like the conversational ability of ChatGPT-4, say, we also will see evidence of mind-like machine entities. So, we're Orga, they're Mecha. There are two kinds of entities now on the planet. And I think actually my feel is the opposite is happening. So as we sort of make progress in the field, we increasingly see that we're building tools, more and more powerful tools. And so I, there's a sense in which, so when the talk wasn't the talk something like the end of AI. So I think this is there's a sense in which progress is actually killing the dream of AI, because every time we make a move forward, the more you understand about ChatGPT, the more you will see it as an engineering marvel rather than as a competing mind or something like that. Now, certainly there's still room for that, but I do think that some of the lesson of ChatGPT is that as we make progress, we also realize that computing is a tool that we have to use. So that's burying that. They call that when you write, they call that burying the lead. It means you're saying the conclusion up front. So I'm going to say that up front, but let me talk a little bit first. I'm going to try to get through this. This is actually, it's sort of a difficult talk for me because there's so much to say about ChatGPT. So I want to say first that it works, and then I want to say how it doesn't work. And I want to point out to the audience how the ways in which it doesn't work are quite fatal for using that technology as a bridge to AGI or superintelligence. In other words, it's a fairly siloed technology. It's a very powerful technology, but it's not going to be a path forward in the way that Sam Altman and other people are talking about in the media. I don't think it's going to work that way, and I'll try to make that case. Okay, so really quickly, before I get into problems with ChatGPT, let me explain why it was a kind of shock. So in my book, what I did was I identified different types of ways that AI systems could infer conclusions from what they know and what they see. And so I said one of the ways that an AI system can do that is by deduction. This is Psycorp. This is Doug Lennet. This is a very rich tradition in AI. And so the classic example is if it's raining, the streets are wet. It is in fact raining, therefore the streets are wet. That's what's called modus ponens. They still use the Latin designation for it, and it has to be true. If it turns out that the streets are in fact wet, and if it's raining, it turns out that it's raining, and if it's raining, the streets are wet. It turns out that it has to be the case. It's necessary that the streets are wet. So that's one form of inference that humans use when we reason. It was also exhaustively explored in the field of artificial intelligence in terms of trying to use deduction to squeeze out what we need for an actual generally intelligent cognitive system. Another type of inference is what ChatGPT, and really what's dominated the field in the entire 21st century. It goes under the rubric of machine learning typically, but it's really induction. Induction is provision of prior example, right? So what you do is you say, like, I've observed every time I've walked out for the last decade, if the streets are wet, it's always been because previously that there was rain falling out of the sky. And so probably it's always a probabilistic inference, but the induction would say I walk out on the next iteration, and I see that the streets are wet, and I say probably it's been raining, right? I mean, you can imagine maybe the sun's out, but it was raining 20 minutes ago or something, if you want the example to sound more. But so induction basically says what I see in the past gives me probabilities about what I should infer in the future, right? So it sort of loads onto our inference what we see. In legal terms, they say like the preponderance of evidence, right? So we constantly are gathering this sort of preponderance of evidence in what we observe, and that gives us a kind of lever to be able to make inferences. And so those inferences, unlike deduction, are defeasible, or they can be wrong. But they have the virtue of tracking sort of like what we're seeing, right? Like they have the virtue of being very empirical. And so pretty much all of machine learning is induction in this broad sense. If you think about when they trained ChatGPT, they took billions of words or tokens, digitized books, megabytes and megabytes of data from a very, very large section of textual content from the web. And they used that to tell the system this is what natural language is. So that's pure induction. You're not actually coding in as an AI, as an engineer. You're not coding in rules that say this is how language works, this is how grammar works, and so on. You're actually just saying, like, look at these pages, these web pages, and then from that build a model of how language works. And so the approaches that we use today are almost exclusively induction. It's been completely, it's completely dominant paradigm in the 21st century. And when I say the 21st century, I mean roughly the 21st century. In the early 2000s, people noticed, hey, we've got a lot of web pages. Web pages are textual content, they're image content. And so all these problems that we're trying to solve in AI, suddenly we've got data, we've got enough data where we can use machine learning or inductive methods. And then the third type of inference that I talked about in the book, and I apologize if this is tedious, but it's necessary in order for me to set up what I want to say about ChatGPT, is something called abduction It's very little known. Some people use the term common sense reasoning, right? But it was originally coined as abduction, and it has a very peculiar logical form. So if you take A arrow B, A therefore B, if it's raining, the streets are wet, it's raining. Abduction says, if it's raining, the streets are wet. I see that the streets are wet. Like I make this observation, this surprising observation that the streets are wet. And then I infer that maybe it's raining, perhaps it's raining. So abduction works from a observed effect back to a selection of a plausible cause in a set of causes, right? And what makes abduction very difficult and also ubiquitous in cognition is that the set of causes can be are basically always effectively infinite. Like maybe there was a air tanker that was flying by that accidentally dropped water on its way to extinguish a forest fire over in the hills, right? Maybe the kids were playing with their super soakers just before I walked out. Maybe there was somebody ran over a fire hydrant just around the corner that I can't see, and it spilled water everywhere. So like you can just keep inventing reasons that the streets are wet that have nothing to do with rain. And it turns out that when we have to figure out like what's going on, we actually do resort to this kind of causal reasoning. Like we look at the effect and then we ask about plausible causes. And the reason it's a difficult thing to program in a machine is that you need an entire sort of fabric or background of knowledge about the world. You need a model of sort of how the world works in order to understand what's plausible and not plausible. So to say maybe it's raining, or maybe it was the kids and the super soakers or something, requires a lot of knowledge about how water gets on streets, what emits water, what sort of devices emit water. So you get this kind of explosion of world knowledge as a requirement the minute you start doing this kind of reasoning, right? And so in the book I said, look, if we can't figure out how to program this kind of reasoning from an effect back to a plausible cause, we're never going to crack this AGI nut. Like we're never going to get to general intelligence. And then ChatGPT comes along and it basically solves a lot of problems, frankly, in this conversational space by using pure induction, right? Like it's not actually doing abduction, right? Like if you know how it works, it's basically just embedding into 100 trillion parameter vector space words, and then the similarity of the words is used to determine probability. So just a real quick, if you want to say something, just give me 1 minute here, John. So a real quick tutorial, or tutorial on how these most people probably already know this, but what GPT does is it takes a prompt, which is what you supply, which is a sequence of words, right? Typically a question. And then it asks, what's the reasonable completion of this prompt? And so the entire inference procedure of the pre-trained, the GPT model, is to say, this is the next word that's reasonable to continue this sequence of words, right? And so it's actually just looking at, here's the next word. And then once it affixes or appends that word onto the sequence, onto your prompt, it takes that entire +1, the word, and it pushes it through, called a feed forward network. It pushes it through the network again. And then when it comes out the other side after 25,000 computers, it's required to do this, by the way. This is a very compute intensive process to do a feed forward like this. This is why you can't download GPT, by the way. Like it's running on over 3,000 servers. And by the way, there's a lot of energy going into, into asking it questions. If you're worried about climate change, stop asking it questions, please. But anyway, so when it goes through the feed forward network, it comes up with another probability for the next word to append. So the reason I think AI is intriguing is because and then the next word is unpredictable, and the next word is and, um, helpful, and right, and like it's literally doing this and pushing through every time it affixes a token, it's pushing it through. um and so there's no abduction in that to return, right? Like that's doing what we call sequence prediction, which is just, I have a sequence of things, tokens. They could be words, they could be heartbeats. What's the next one in the sequence? And that's a well-defined species of induction, not abduction. So the question is, you know, do we actually need all this fancy schmancy world knowledge and so on, or is it the case that if we just have enough data and enough computing power, and we have this transformer architecture, right? Can we actually just simulate all this intelligence, and we were all wrong? All the old guy, and including myself, like we were all wrong about AI. So I think I wanted to push to get to that point. I wanted to push to get to that point. So should I stop for a second and or I feel like I'm really pushing on this, but like
No,
should I
no,
stop?
that's I mean, this is all, maybe other people out there know this background, but this is really informative to me.
Okay,
But let me just ask one clarifying question, but then
sure.
you go ahead. Um, but so ChatGPT is disparaged by some people as a kind of supercharged sentence finisher. Um, is that is that actually? It sounds like that's kind of what you're saying. Is that fair to
Yeah.
say? All right, now I'm
Yeah.
going to mute myself again, and you just go ahead.
No, I mean, so I think like the 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 frustrating thing about the GPT stuff is anybody in the field will freely admit, if they're being honest, that it's an extremely powerful result. And but when you look at actually how it's working, we thought it was going to involve a lot of cognitive insights, a lot of this. It turns out that we just need a lot of data and really powerful computers and this transformer architecture, which was a little legitimate innovation. But yeah, that's basically what it's doing. It's just it's completing the end of your sentence, and then it's running it through, and then it's completing the end of this slightly larger sentence. And so you think to yourself, like, how can it possibly, make a haiku or answer like complex questions about moral reasoning by doing this? And so I think like there's a sense in which like I want to celebrate like the emergent. This is a runaway. I call these runaway phrases. Like if you say emergent, people will start thinking of minds and consciousness. That's not what I mean. But like I think there's an emergent property that we can fairly ascribe to GPT. The engineers in OpenAI themselves actually didn't think that it was going to be this good at answering questions, having conversations, generating poetry, generating reason, taking tests. I mean, there's very little that it can't do, although it's terrible at playing chess, by the way. I looked it up. So I think so that is all it's doing. And I think what I want to say is here's the problem that no one's talking about. Okay. So here we have this wonderful result, and here's the problem. Very simple chat, and I'm talking about GPT-4. I'm talking about the latest and the greatest here. Like there are very simple conceptual problems that if you know exactly how it's working, um, it will fail on. And so there's a sense in which like you have 95, 96, 97% of this fantastic output, right? Like this, you might as well be talking to the smartest person in the world, right? um and then 3% or 2% of the time it comes up with a completely ridiculous answer, and then when you challenge it to say, look, like, why did you say that, it confabulates. It literally lies to you. Like it doesn't know what it doesn't know, like the Socratic principle, right? So what I'm saying is that like celebrate the 97%, But the 3% is actually fatal to making scientific progress towards AGI, because we simply can't have a model that has the equivalent of a brain lesion, right? Like, just can't, like, there are certain things that it just will not understand. And I can give examples, and I'm going to give examples about this if I can find a way not to bore everyone. But there are certain things that it just doesn't get right. And by the way, it's very difficult to predict beforehand what it's going to get wrong. It's extremely difficult. You just don't know. So this is part of the problem, right? Like, imagine embedding this in a nuclear submarine, where, 3% of the time it's going to come up with, it's going to hallucinate imaginary causes to events. And then when you challenge it, it's going to come up with a confabulated story that sounds perfect, but it's like talking to somebody on LSD. Like, it's like none of it is actually true. And you don't know when that's going to happen. That's the problem. You can't, in principle, you cannot, because of the nature of that architecture and the way that it works, there is no principled way to say beforehand, hey, we're going to have a problem if we ask it these type of questions. So you have this, you basically, we have a crazy, really, really super smart, but completely insane, thing that we're interacting with. And we're expecting that to take us to, Sam Altman said we're going to use this to solve labor productivity and so on. It's like, no, like, it's actually not it's not a sound basis upon which to build further AI. So the irony of it is, I think that we're actually siloed. I think it's a fantastic result, which is the sort of paradox of it. But I think it's also it's a siloed result where an enormous amount of compute power and R&D dollars are going into something that we can already tell is not going to take us to the finish line. We can't allow something where we can't predict when it's going to go nuts. And, like, we just can't do that. And so, getting back just really quickly, getting back to the question of inference, the reason that it does this is that it doesn't have what we call a world model. It doesn't have an actual model of the world that it can rely on. It doesn't have background knowledge, right? And so whenever something completely insane is the highest probability answer, there's nothing that it can fall back on and say, wait a minute, that sounds a little wacky. Why did I just say there's water on the street because a Martian came down and so on, and why am I defending that against all odds, right? So so the lack of a world model, I think, does prove that there are necessary conditions for us to move AI forward in a confident, stable fashion. And it's not, as strange as this sounds, it's not the large language model phenomenon. Like, it's actually, this is not the thing that's going to get us there. And so, yeah, so let me stop there. I don't know like when to start and stop, but like, yeah,
Okay.
like if there's any, yeah.
Well, I've got a question. I'm sure other people are going to have questions too. Why can't it learn from its mistakes? I'm assuming that all the mistakes are being processed by the ChatGPT people, and people are designing all these systems. I happen to be playing with a system called Pi, which is very clever and impressive. But aren't these programs learning from their mistakes so that they can have fewer of these hallucinations and less confabulation and that sort of thing?
Yeah, absolutely. There's a, what's it called, reinforcement learning with human feedback, or RLHF, which is actually a process that OpenAI uses to continually improve the models. um the problem is that if you're patching, I mean, this sounds really negative, but I think it's probably the best way to say it. If you're building software and you see that it doesn't get something right, and then you patch it after the fact, it's like building a boat that has 37 leaks. and then you say like, I'm just going to patch them, and if a 38th come up and a 39th come up, like at some point somebody's going to say like, you didn't build the boat correctly, right? So like there's like, yes, we can continually find, you know, when confronted with weakness in the model, we can find a way to patch it, right? But the more patching we do, this becomes a complicated software project, not a principled answer to intelligence. Does that make, do you follow what I'm saying?
Yeah.
Yeah. So okay, so that's what I'd say. So like, and by the way, like I dug up some examples so this isn't so abstract. Um One of the things that, so there's a really wonderful paper that came out in the UK called The Reversal Curse. LLMs trained on A as B failed to learn B as A. And so it turns out that if you have a model, and they did this with GPT-4, they did this with the latest model, and you ask it, who is Tom Cruise's mother, it will give you the answer. Apparently his mother is Mary Lee Pfeiffer. And then if you ask the reverse with no manipulation of the prompt, you just ask, you know, cold, who is Tom Cruise, who is Mary Lee Pfeiffer's son, it will not be able to answer it. It won't connect the two, actually. So so 79% of the time it gets the first question, A is B, and less than 40% or 33% of the time it gets the second, which is just B is A. So it's clear that it has a basic failure of understanding logical deduction, right? Even a 5-year-old child would say like, what are you talking about? Like, you just told me his mom is, you know, so that means that he's his son. Like, what, you know, like, so it understands the language, but for some reason it can't invert A as B and B as A in these circumstances. That sort of tells you that like there's no there, right? And so um that will no doubt get fixed since this paper came out. This paper came out on Gary Marcus's Substack about 2 weeks ago, and since this paper came out, it's probably already patched by OpenAI. But the problem is that you can't just keep plugging up holes in your boat, right? Like, you have to build it so that it doesn't have leaks. And these are fundamental inabilities to understand the world from the GPT model. It's a fundamental inability for it to understand how things work. Um, so yes, did that answer your question?
Yeah. Yeah. Thanks a lot. I mean, do you want to open this to questions now? Because I have more questions I can ask you, but if you've got more stuff that you want to say to kind of let us know what's going on.
This is like a hard talk for me to give because like I'm like, ChatGPT is relatively new, and so like I've spent the last year trying to understand it and then how to talk about it. And it turns out that like I'm going to give a talk over, I'm doing a book tour over in Europe this month, and like all everybody wants to talk about is ChatGPT. So it's
Right.
like it's difficult to, like, you know, it's like all of a sudden, like, you know, this is the only thing we're talking about. But so very let me go through some other information to get like a slightly fuller picture to the audience.
Mhm.
So one of the other things that troubles me about the GPT models, or just the large language models generally, there's a task called the event causality identification task, and it's basically a fancy term for two events happen in a description and they're connected either causally or they're not connected causally. So let me give you an example of a causal connection of two events that's actually described in language. Minutes after a woman was suspended and escorted from her job, she returned with a gun and opened fire, killing two and critically injuring a third coworker before taking into custody. The question is suspended, as in fired from her job, and the injuring event, are they causally connected? And the answer is yes. Like, most people would say, like, that's not a random thing that, you know, she shot somebody after she was fired, right? Like, and so it turns out that there's a couple of points to make about this. One is that, surprisingly, um, Chat GPT does a pretty good job of these kind of answering these questions, as long as there is a causal connection between events mentioned in the passage. but if there is not a causal connection, it tends to insert one. So some of the bias of the model is you're asking it about causes, and if there's a cause, it gets the answer correct. But if there's not a cause, then it actually will confabulate or make up a story about how they're connected. So it's really eager to sort of and so I was thinking about this in the context of like, let's put this in a self-driving car, and yeah, and then it's like inventing things that are causing other things and so on. Like you're very clearly going to get into a really bad situation. So here's the second point that I wanted to bring up. The trade-off problem is, this is something that I wasn't aware of until just doing the research for this talk, but like if you fix non-causal hallucinations, I assume the audience is familiar with the problem of hallucinations, where it just makes something up and it doesn't have anything to do with reality. So the attempt that OpenAI does, using reinforcement learning with human feedback to fix non-causal hallucinations, actually exacerbates the tendency of the model to assume causal relationships between events. So fixing one thing actually makes another thing worse. And this is more kind of this is yet another sign that there's some sort of fundamental problem lurking in this as a path to general intelligence, right? So I'm gonna mention a couple of other things, and I don't want to feel like I'm piling on. I don't want people to feel like I'm piling on, because I do think it's a legitimate innovation in NLP. It just so happens that it has all these unexpected negative consequences to it because of the way that it fails. So the other problem is that, I don't know if everybody knows this, but that the cutoff for the data for you to converse with it is September 2021. Some people put it at January 2022. It's unclear. OpenAI was sort of cagey about exactly when the data cut off. But so the model doesn't have any understanding whatsoever. It's like a complete amnesiac about anything that occurs after September 2021. So like, we don't, by an AGI, we mean something that can in real time answer questions about what's going on in the world, right? Like, we just can't do that. We're constantly, like, this model is, is basically blind past that point. So we're constantly interacting with something that has a picture of the world that's already gone. I think that's really troubling if we think we're interacting with the mind, that the mind is just sort of blind to what's going on around us today. I think it's also very limiting, frankly. There's a lot of things we can't do with that in terms of real-time reasoning, because it just doesn't know anything past September 2021. The other problem is, if you want to, rather than patch it with reinforcement learning techniques, if you want to actually retrain it, you're going to have to use, and I did all the math on this, it comes out to 3,125 servers running continually for over 3 months. So there's no way to tell the model, hey, we need to update, not a superficial patch, but we need to create a new model of the world. That's going to take over 3 months, a couple of $1 billion, from Microsoft, and over 3,000 servers. So I think, like, just in a more kind of like the elegance of it, the aesthetics of it, I don't like this kind of approach to AI, right? Like, this is not something that, anyone other than the hyper rich, super funded can do. And it's actually fairly inflexible in terms of us being able to use it on a day-to-day basis. It's kind of like a statistical mashup of Wikipedia. So if you need to know stuff about the past, it's really brilliant at telling you. It's like the smartest person in the room by far at telling you stuff that's already happened. But if you need to reason about things that are going on right now, today, it's actually of almost zero value. It just doesn't know what's going on today. So I think there are some really big problems that people, somehow the media, somehow, the participants in in the discussion online about it's, nobody really highlights this. Like it never really comes out that people realize, oh, wait a minute. So anyway, like let me stop there. Like I've
Okay.
been pushing on this
I,
hard. So
yeah,
yeah.
I'm seeing some questions. One of my colleagues, okay, Catherine Detweiler, you may already have said this and I missed it, but do the 3% fatal errors all pertain to a select set of logical procedures, or do they come from a lack of world model?
Yeah, I mean, there's no way to tell when it's going to fail. And so I would say that the common denominator is the lack of world model.
Yeah.
Yeah.
Okay, I've got another question from a colleague at Stevens. This is Jim McClellan, historian of science. I asked ChatGPT how many chromosomes early humans had. First answer was 24. I asked about Homo sapiens. It replied 23. I said its first answer was 24, then 24. How to explain it? It replied, I apologize for any confusion in my previous responses. To clarify, all extant humans, Homo sapiens, have 23 pairs of chromosomes, totaling 46 chromosomes. So Jim's point is that it seems to have corrected itself after making initial errors.
Yeah. So, and it will do that. And here's yet another frustrating. Like I said, it's like, I hope this doesn't, by the way, I hope I don't offend anybody by using this example, but it's like you have a friend that has a severe brain lesion, right? And so like there are certain things that he or she will like, they're the smartest person in the world, right? They have 150 IQ, but there are certain things that they just don't get. So with ChatGPT, it will admirably correct its mistakes on some occasions, and on other occasions, and we don't know why the one and why the other, it will double down and dig in and insist on an explanation that's manifestly false. So we don't know why the one and why the other, right? Yeah.
Okay, so here's another question. Maybe you've already answered this, but this is Joel Saad Lessler. Would you agree that ChatGPT is a really powerful search engine that could be productivity enhancing as long as you recognize its limitations?
Yeah, I think that's probably true. I don't think, as an adjunct to that question, I don't think the business case is particularly strong. There are already signs that the public interest is lagging. In fact, the June was the highest number of hits to the API, June 2023. It's actually going down now. So people are already sort of ho-humming it. The business case tends to involve enhancing conversational experiences like Alexa on steroids, as the response, like search as a kind of adjunct to search. These are all sort of downstream applications. So it's a little odd that we have this really powerful result in AI and the business case is fairly flimsy. It came out in November of 2022. If you would have told me that we could basically pass the Turing test with a technology in November of 2022, and a year later we were still trying to figure out how it's going to make money, I would have told you must be super high, because like I would have thought it would have made $1 trillion by now. So there's something really strange going on that it's actually not causing a major splash in the business world. But I do agree with the question that I do think it can be an extremely valuable aid. Just keep in mind that it might tell you something that's completely false, and it's going to be up to you to have a more classical understanding of the world to know that. So, but yeah,
All right.
anyway.
Here's a question from a philosopher colleague of mine, Greg Morgan at Stevens. Isn't it likely that all of us might also give 3%? I'd say at least 3% erroneous answers to questions. And in other words, in what sense does this make ChatGPT different from humans, this error rate?
Yeah, I mean that's a fair point. Like people aren't cognitively perfect as well, and we certainly do make mistakes, and even basic statistical mistakes. Like Kahneman and Tversky, showed that we even sometimes can't reason statistically, and so like that's certainly the case. The problem with ChatGPT though is not that it occasionally makes mistakes and we can put that within a framework and understand it. It's that it occasionally becomes a completely insane thing, right? Like it's like you're talking to somebody and then you realize that they took LSD like an hour ago or something. It's like, wait a minute, this is a completely different, like, what are you talking about? And so like I was looking actually in at someone who played a game of chess using Chat GPT 4, just kept querying it, what should my next move be, and was playing, actually was able to play chess. And at some point, GPT-4 gave a very strong move, and then he was trying to decide what to do, and then GPT-4 decided, no, it's not a strong move. It gave the weakest possible move, and then when the human interlocutor said, like, hey, are you sure you want to do that? Like, that's a way weaker move than your first one. It just dug in and said, yeah, this is what I want to do. And it's like it went from being superhuman chess player to like, somebody that's played chess 5 times and it didn't know the difference. Right. And so that's, I think, the difference. The human case is, generally speaking, we make mistakes that we can kind of, we can kind of track down the mistakes that we make when we talk to each other in a community. Right. Chat GPT will make mistakes that, we don't really understand how to put in a context. So I don't think the cases are exactly analogous. Is that'd be my response.
I've got, so I'm just wondering about, this is almost like a sort of a question about marketing and politics. This extraordinary extinction uh, letter that a whole bunch of people signed, including Bill Gates and Altman, the leaders of AI, the makers of AI, the people who are going to try to make a lot of money off it, warning that it can really harm us. What is going on with that? Why would they say these things?
I don't know. Like, this is like, why are doomsdayers doomsdayers? And and why are utopianists? Like, I think this is sort of like part of like human psychology. It's almost like it's over my pay grade to answer. Like there's a very clear distinction between what our technology can do in the here and now, or any logical extent, foreseeable extension of it, like misinformation, deep fakes, viruses that bring down financial markets and so on, from bad human players and so on. Like, there's a very clear sense in which we can attach significant risk to computational technology. But I think when people are signing the document, that I know what you're talking about, the petition, I think that something that's going on in their mind is that we have this new creature that's appearing on the planet, and it's smarter than we are. And if we don't do something about it, it's going to come up with a plan that we're just not able to thwart, us, we being, dumber than it is, and so on. And I think that's just kind of like, I don't see any, I mean, it's incredibly frustrating to try to counter that argument, because you find yourself arguing with somebody who, like, for all practical purposes, you're arguing about replicants in Blade Runner, right? Like, you know what I'm saying? Like, it's like, okay, like, well, what are we talking about? And of course, if you point it out directly, like, are you saying the thing is alive and it's going to come up with, motivations that are counter to ours and so on? You'll get a pullback and you'll get more sober language and so on. But that petition, I think, was driven a little bit by that, like, HAL 9000 thing. And there's no way to get rid of that in AI. I've thought about this endlessly. Like, how do we make AI an actual science where people stop talking about it like we're building a creature, and it's going to come alive and it's going to make decisions and so on? Like, how do we do that? And I think, like, I've never, I, I'm not confident that we will ever get rid of that like aspect of artificial intelligence. Um, let's just hope it doesn't cause us real harm. Like, let's just hope these petitions are just, blowing in the wind, as it were, and they don't really, you know, but yeah.
Well, so here's a follow-up then, I guess, especially given your last comment. There are some people now who are saying we need to regulate AI, that there's going to be a weaponized AI arms race between the US and China. I guess that's already happening now to a certain extent. Certainly a lot of funding going into defense applications of AI. Is that something you're worried about? And if so, what can be done and how can AI be controlled? How can it be regulated? Is there any way to do that?
Yeah, I think it's incredibly, like, I think it's really, really dangerous. So, like, the most dangerous aspect of AI is the one we're not talking about right now. It's not conversational AI. It's not LLMs. It's actually autonomous navigation systems, right? And so when you can code not only how to get to the destination, avoid countermeasures and so on, but you can also code in planning and decision making that happens autonomously and aside, apart from the humans. Like, you're basically you're placing some of humanity's future into the hands of these systems. And I think, like, autonomous navigation is impossible to stop. Like, it's already really been demonstrated with drones. There you have a three-dimensional space. There's not a lot to hit up in the air. So drones work a lot better than cars do. Because cars, you got a lot more objects to consider. But I, I don't know if this answers your question, but I think, like, the AI will increasingly be used for it has obvious advantages in warfare if you want to limit human casualties on your side and you don't have to put any humans into harm's way. Right? So I think it's going to be there's going to be a huge incentive for Congress, for the US government to approve these. I did 2 DARPA projects actually previously, and it's not something that's relevant here, but, like, I think there's going to be a huge incentive to try to keep pushing AI into warfare such that we can reduce human casualties. And I think, if there ever was a chance that we're going to push over a singularity, like we're going to go over some kind of line that we can't stop, it's if we automate warfare too much. That's something that I actually do worry about. That's different than there's going to be this creature that decides it wants to exterminate us and make us all paper clips. That's an actual decision that we made, militarily made, to put autonomous navigation systems in stuff with weapons. And I actually do worry about that. Yeah. I don't know. That's a subset of what you're asking. I don't know if I answered your whole question.
No, that's no, I think you nailed it. You went right to my main concern, and I still wonder how you control these things, which are essentially programs that you can put in a wide variety of technologies. And it's not like building nuclear bombs where there's a gigantic footprint that you can monitor with satellites and all that sort of thing. I mean, how do you, if you decide you have some kind of arms control agreement between the US and China, let's say, how is that even monitored? How do you know that either side is complying with the treaty? That's
Yeah.
the
I mean, I think it's a huge problem. And I don't think that we have, so, as this is, like, this is just almost trite to say this, but, like, institutions always lag behind tech, right? There's always a lag. And I think, like, there's a sense in which, like, we don't have answers to these questions because the capabilities of the tech is way up in front of our ability to talk about it. I want to stress again, though, that I think the sci-fi discussions are unhelpful because there's very real dangers that we actually do need to talk about. So it could be entirely possible for a foreign actor to steer an election, I mean, this in 2016 we talked about this with Russia. but like it could be entirely possible that we could actually have results like that, because there's so much misinformation that's being put out automatically. There are speeches being made by people who are actually not even, like literally not making the speech and so on, with AGNs and that technology to generate deepfakes and so on. That's a great technology in a science aspect, but it just has so much opportunity to go awry. I don't know, like I don't right now the government doesn't really have answers to this stuff. It's very obvious. But yeah, like in terms of the actual military warfare, I have a friend of mine who's working in a company that's designing autonomous submarines.
Uh,
And I can say this part about it. I can't say all of it, but I can say this part. I can say this part, like the part of the motivation that the DoD, part of the reason that the DoD is funding his company is if we have a complete failure, to be able to communicate with out on the field, the systems can actually make intelligent decisions about what to do in the absence of human intervention, right? So they want autonomy in the case that we have a categorical failure on our side, a communications failure on our side, so that we can't actually get messages out. So then we're going to put that, in the hands of the autonomous systems, and I think like when that sort of stuff starts becoming a reality in the next decade, we're gonna have a lot of problems. Yeah, but this is not. By the way, this is not ChatGPT though.
yeah, yeah, yeah.
This is not
No,
ChatGPT,
but it's
but it is a
still,
transformer architecture. But anyway, go ahead.
yeah, but
Yeah,
it's still AI. I mean, and
yeah.
that's so I'm worried about it all. All right, our time is up, Eric. I mean, I learned a lot. I don't know about the everybody else out there, but I'm guessing they learned a lot too. This is really helpful to me to put this stuff in context. You're not necessarily reassuring, especially at the end there, but that's okay. We shouldn't be reassured. We should be worried about this stuff that's happening.
Yeah, no, I mean, like, so, I wrote a piece recently that where, Sam Altman said, like, what's the strategy of OpenAI is like to figure out general intelligence and then to use it to ask it how to make more money. And then, and right. And then Dennis, Hassabis, the guy, the deep brain guy, he said something similar. He said, our strategy is to figure out intelligence and then use that to solve all the other problems. And I think so, like, one of the things that, and we didn't really get to this in the talk, but one of my real worries is that we have a very narrow and anti-humanistic look at, sort of understanding of technology right now. We're very wowed by the power of systems like ChatGPT. And so there's not, we don't have a strong humanistic impulse right now to say that we build this stuff and we need to decide, what to do with it. The idea that we're going to build a general intelligence, first of all, we still don't have a clue how to do that. But the idea that somehow we're going to figure out these very complicated human problems that involve human emotions, human judgments, and so on by asking, a disembodied intelligence to decide that is kind of like Silicon Valley. Like that's like, like those are just comments that reveal that we don't have a stronger worldview. We don't have anything to fall back on. And so we're kind of just following along, what the latest tech is, and then what the leaders, the Altmans and so on, say about the significance of that tech. And I don't think that's a formula for a healthy society to just say, like, let's find out who's building the fastest car, right, and then let's just ask them what to do. We wouldn't do that in high school, right? You so but I think that's a lot what's going on today. Yeah, so that's,
Uh,
but yeah, anyway.
I just want to let people know that that you can find a lot more about what Eric thinks about all these trends on his Substack. I just, yeah, okay, good. Somebody just posted a link to your Substack, one of your fans. Thanks a
I
lot.
appreciate it. Yeah, thank
I,
you.
I really
It's always a
appreciate it.
pleasure.
I'm sure we'll be talking again soon. And thank you everybody for showing up and for the great questions.